that graph is going to be stretched by 4. Your vertex is at 0, 0, and the slope is up 4/1. And you repeat that on both sides. So there is my lovely graph for number 1. Number 2, the negative tells me that this graph is reflected. So being that it is reflected, your vertex for every one of these on day 1 was 0, 0. It's reflected, and that 3 tells me it is once again stretched by 3. So it makes my initial slope down 3 and over 1. So the graph is, oh, I missed. The graph is open down like a frown, and it is, like I said, reflected and stretched. Okay, number 3, we have y equals -1/2 x. So in this graph, alright, so it is muted. Alright, in this graph, my slope is -1/2, and my values are changing. Give me 1 second. I can hear that echo, and I think it's the Apple TV. I'm going to mute this one and unmute. And there. Alright, now we should not have an echo on our end. So, our graph is reflected. And now that 1/2 tells me that the graph is compressed. So it is compressed by 1/2. That means that this graph is shrunk, basically. So it's going to go through 0, 0, but up 1 over 2, up 1 over 2. So you can see that this graph is wide. That's the compression. This graph is skinny. That's the stretch. Oh, it does. You're right. Thank you. So this is y equals 1/2 absolute value of x. And then because of the negative, the graph is going to be reflected. So your final graph should actually go down 1 over 2, down 1 over 2, and opposite direction. And it should look like this. Thank you. Okay, number 4, y equals 2, absolute value of x. So again, this graph is stretched, so it's going to be tall and narrow. Number 5, that negative tells me it's reflected. And then the 0.2, well, that's really like the same as saying -2 over 10 or -1 over 5 absolute value of x. So because that is between 0 and 1, this is once again compressed. So down 1 over 5. So we can see once again this graph is much wider than the regular graph. Its range is going to be flipped. So the range of a normal graph is y greater than or equal to 0. Since this graph is reflected, it's y less than or equal to 0. So its range is also flipped. Okay, number 6. That 6 tells me it's stretched. So it is super narrow up and down. Okay, number 7. A 1/3 tells me my graph is compressed. It goes through 0, 0, up 1 over 3. So again, nice and wide. Number 8, the negative tells me it's reflected. The 2 tells me it's stretched. So it's going to be open down like a frown, and our slope is down 2 over 1. And then you do the reverse of that, and you go down 2 and left 1. Once again, all of these graphs are only stretched or compressed, so all vertexes are at 0, 0. So this graph is compressed. Your slope is 3 over 5. And again, compressed. And 10. 10 is reflected and compressed. So it is open down like a frown, and your slope is 1/4. 11 has a bunch of different answers, but it says write an absolute value function that has a maximum. So if I'm looking at like these examples from up above, this graph has what we call a min because the graph opens up. This graph has a max because it opens down. Min, max. So a max is a graph that's opened down like a frown. So for 11, any answer would have done as long as you had a negative in front of your absolute value. So you could add -1, 10, 11, a million, 100, a fourth, a fifth, etc. Does that make sense? Fantastic. All right, so then the next thing we're going to do, all right, so for part 2, once again, we were looking at seeing those key ideas and parts. So I'm going to let you go through, kind of just look at these graphs. If you have questions at all about any of the vertexes or domains, range, etc., transformations, I will gladly answer any of those. So again, I'll let you kind of check on your own, and then if you have questions for me, I will gladly answer. Yes. So the idea is that the equation for the absolute value is y equals a absolute value x minus h. So since this is a positive right here, it's kind of like saying a minus. So that's why it's a positive, but our graph moves negative. So pretty much whatever is inside your vertex will be the opposite on the outside. So like if that's a positive 2, then my vertex is -2. If it's a positive 1, my vertex is -1. If it's a, I didn't mean to know that, etc. Okay, here's 7 and through 10. So number 7, your vertex is at 2, -2. In 8, my vertex is at -1, 4. 9, it's at -4, 2. And 10, it's at 1, 1. And then there's 11 and 12. So my vertex in 11 is at 2, 4. My vertex in 12 is at 1, 1. Did that help like a lot today? I feel like sometimes, you know, it takes that third or fourth time to really see something. I actually really thought the Khan Academies were really helpful because it gave you that instant feedback. It said, okay, no, not that, but this. So I'm hoping those on Friday helped you as well. Are there any questions on the homework assignment that you have for me that we maybe haven't touched upon or gone over? Because today that's really the goal, is what questions do you have for me? Never. Yes, the absolute value functions domain is always all reals. If any of you miss that on your quiz, I'll not feel bad.
Are we having just a quiz on absolute value?
Yes, ma'am. Because I feel like this is super important. It's something that kind of like doesn't go away. The next unit we're going to look at will be inequalities. So that's like where you shade above or below the lines. And we actually do absolute value shading. So I feel like it's really important to understand how to graph an absolute value. And a lot of the stuff we talk about with absolute values is going to directly relate to what we talk about in chapter 5, which is quadratics. So the vertex form of an absolute value is the same as the vertex form of a quadratic. So I like to really make sure we're focused and good on these as well. All right, so let's go over and talk about some of these problems. So let's see here if I can print off a blank one, because I just realized the copy I have, yes, awesome, is all written on top of from doing it period 4. Okay. So just kind of like thinking ahead, guys, obviously we've done all the notes on this. We're obviously preparing the quizzes just on this unit. The quiz will most likely be a Friday, Monday combo. So like group B will take it Friday, you guys will take it Monday. Does that make sense? So, and then anybody that is fully remote would be taking it on Monday. So you guys will take this quiz on this next Monday. Good? I mean, that gives you we're going to pretty much review for the remainder of this week. All right. So number 1, how does the graph of y equals absolute value x plus 9 differ from the graph of y equals the absolute value of x? So how do they differ? Anybody want to tell me what the answer to this would be? What do you think, Reese? Yeah, the vertex points are definitely different. So how are they different? We know, now that we know they are different, what is the big difference? What does this plus 9 do to my vertex? God, what? Yeah, it makes it a negative. So it makes the vertex a -9, 0. So what does that mean in terms of, because this is asking for the transformations, what does that mean this graph did? What does a -9 on my vertex do to my graph? Does it go up, down? left, right?
Yeah.
If it was down, it would have been this number or at the end.
Left.
Yes, exactly. That's going to move it left 9 units. Hey, at least she's trying. Okay, number 2. Y equals the absolute value of x minus 8. How does this graph differ from the other graph? I was trying to tell them they could unmute. Go ahead, Olivia, what do you think?
The vertex of the first one would be -8 or +8.
Perfect. So the vertex is going to become a positive 8, 0. So what does that tell me in terms of a transformation? What does that tell me in terms of a transformation? Is my graph up, down, left, right? What do we think? Oh, yeah. See, so one of the kiddos on my other group is answering. Yes, hold on. Repeat that because I had my volume totally off. Good?
Right 8.
Perfect. It is right 8 units. Oh, how'd you know that was Hannah? They can't see your name, so that was awesome that no one knew who you were. All right, so yes, it went right 8 units. So both of these graphs then are changing our function. So our equation is y equals a, absolute value of x minus h plus k. So what variable did both of these affect? Which variable? A, h, or k? A, h, or k? H, fantastic. So they affected the h value. So what that means is that the h value, if it is changed, that's my left or right. What's the k value then? The k value is going to be what? Olivia?
Up or down?
Fantastic. It'd be awesome if I could spell. So let's look down at example number 3 then. We have, how does the graph of y equals the absolute value of x minus 2 plus 4. So somebody tell me, what does the negative 2 do to my graph?
Right 2.
Yeah. So fantastic. It is good. No, wait. Yeah, right 2. Good. I started to question my sanity for a second.
I'm so confused.
There's like 5 or 6 kiddos on from group B. All right. How about the plus 4? Anybody want to tell me what that plus 4 is going to do? Noah?
Down towards
Yeah, who actually, so it's going to go up.
Up. It's on the medium time, not down.
Yeah, so anything outside the absolute values does what the sign tells us to do. So it's going to go up 4. So that means that my new vertex is at 2, 4. So my vertex would be at 2, 4. Number 4, how does the graph of this example change? So let's start with someone I haven't heard from. So Reese, go ahead, give me one of them.
You have your slope shows -3.
Okay, so I have a new slope. My slope is now 3. Excellent. All right, what does the negative in front of that do to my function? What does a negative do? What's the word for a negative? Ethan, you know what a negative does?
Not sure for that one. For the 5, would make it go up, or would make it go right.
Good. All right, I'll take that. So the 5 is going to move it right 5. Olivia, do you want to tell me what that negative at the very beginning does? It does. That's that fancy word, reflected. So it's going to flip it, right? All right, so how about that negative 11? Miss Lindsay, you want to tell me what that negative 11 does? Yes, it would. It's going to go down 11. And Reese already told me it has a slope of 3. Now, we have a word that we like to put that when something has a value greater than 1. So, yes, my slope is 3, but what's the word? What does it do to my graph? Good? It's stretched. Fantastic. So, holy moly, this graph had a lot happening. It was stretched. It was reflected. And my vertex is 5, negative 11. And last but not least, a negative. We should all know by now a negative out in front does what? Reflected. A 1/7 though, instead of stretching it, now my graph is going to be compressed. The positive 7 is really like it's really exactly like a negative 7, so instead of right, it goes left. Okay, and a negative 5 tells me that my graph goes good? Down 5. Awesome. All right, guys, so your homework is that next page in the packet. You're doing the matching. All of the matching answers are on the back. You're not uploading this because tomorrow we're going to do like an electronic kind of answer key so I can get instant feedback from what you did. So basically, you have 1 through 12 you're doing over here. There's answers A through L. So you're just going to match those A through L's to the 1 to 12s. The 1 through 6 are identifying the vertex. The 7 to 12 are identifying the equation. So you can kind of look at it and be like, oh, well, A is an equation, so it has to be 7 to 12. B is a vertex one, so it has to be 1 to 6. So I kind of even eliminated part of your answers for you. Good? Any other questions from anybody, whether you're on the call or in person? Anything you need to know from me? Anything you're still confused about? Fantastic.